Hi, Advanced Algebra 2. Today I'm going to take you through some notes on how to graph radical functions. We're going to focus specifically on square root and cube root functions with the graphing. What's nice is the method of graphing that we're going to use is just like the graphing method that we've done before. So the first thing is that you want to familiarize yourself with the parent functions for square root and cube root functions. So remember, the parent functions are the most basic type of functions, and so they are right here on your notes page. So there's the most basic square root function, and here is the most basic cube root function. So it's just f of x or y equals the square root of x, and then f of x or y equals the cube root of x. So let's look at the square root. A couple things to notice is, first of all, that the graph does have a beginning. And so that's right here for the parent function at 0, 0. The graph does not continue through that, and if you think about it, we can't put in negative numbers for x, because if we did, then we would get an imaginary number, a non-real number. So with the square root function, our graph of the parent will start at 0, 0. And then you'll see the curve, and it's this type of motion here. You see the point 1, 1 graphed, and that's because if you take the square root of 1, you get 1. Now, only positive, because if you look at the function that you're given, there's no sign in front, which means that it's an understood positive sign. Also take a note of the domain and range. So the domain, our x values have to be greater than or equal to 0. They can't be negative, or we won't get real numbers. And then the range, because of that, is also greater than or equal to 0. You can tell what the range is because if you put your eyes along the y-axis and start at the bottom and move up, you'll see that the curve shows up at 0 and then continues where the y values are positive. Now look over at the cube root function. So things are similar, but key differences. We do have a point at 0, 0, but notice the graph does go into the positive and into the negatives. And that's because we can take the cube root of both negative and positive numbers. You'll see this little jig-jog motion that the curve does in the middle, and that is very typical. Now, because we can take the cube root of negative numbers, 0, and positive numbers, our domain is all real numbers. And then because of that, when we take those cube roots, we get negative, 0, and positive. So our range is also all real numbers. And you can tell that as you look along the y-axis, you'll see the curve in the positive and in the negative area. So you do want to become familiar with the parent, square root, and cube root functions, because then, of course, we're going to have other numbers introduced into, and we're going to talk about how the graph will shift from those parent graphs. Also, notice that the domain of the square, or really even any even root function, is restricted. That means we have to make sure that there are only positives. And then because of that, also 0 and positives. And because of that, then the range is limited. But notice that the domain and range of the cube root function are not limited. And that's just because of the nature of the cube root. You can input a negative or 0 or a positive cube root, and then you will get negative, 0, and positive numbers. All right, a little bit more talking through concepts, okay? So guess what? Cube root and square root functions are transformed by those a, h, and k values in the same way that other functions that we have studied are transformed. So I have another core concept for you from the book, and this is a chart, which this is general notation, okay? And it won't make a lot of sense to you, but if you look at the examples, and then also if you write down these two general square root and cube root equations. So in those you can see that I have put in the a, h, and k value. We can also have our a value be inside the square root. So I'll write that as well, and you can too. So cube root, and we know that when that happens, we have horizontal stretches and shrinks. Okay. Now, once you get those written down, then look back, not the f of x notation, but the examples. And you can see how the a, h, and k values affect our square root and cube root functions just like they have affected other equations that we've studied, quadratic, absolute value, linear. So here we have an h value subtracting, so we're going to go 2 units to the right. If we look down in the next row, here we have, this is a k value because it's outside that square root, so 1 down. Now when you have a negative, either a value that is inside the radical or outside, then that means that we're going to have a reflection. So if it's inside, it's across the y-axis, and outside, it's across the x-axis, just like before. And then finally with our horizontal stretches and shrinks. So if our a value is inside the radical, we've got horizontal stretches and shrinks. And you'll see that the factors are opposite of what you'd think. And then with vertical stretch and shrink, it's going to be outside the radical, and it'll be a multiplier. And so a stretch will be greater than 1, and a shrink will be less than 1. So now we're going to use that information, and we're going to graph some of these functions. So we're going to start with the very easy parent function, so the square root and the cube root. Now, when we put inputs in to graph, we're in control. We can do whatever we want. We need to keep it positive, and we also want to include 0. So let's start at 0. And then let's use perfect squares. So positive 1, positive 4, and positive 9. We do not have to go by ones, 1, 2, 3. And if we do that, we'll get decimals. So let's just do numbers that are perfect squares and make our work easy for us. So I am using this is my parent square root function. So the square root of 0 is 0. The square root of 1 is 1. And we're doing the positive because there was no negative sign indicated out front. So that means that we are to take the positive square root. Square root of 4 is 2, and then the square root of 9 is 3. So notice I'm all positives, both in my x and y. So I'm going to give myself lots of positive space, and that will work for us. All right, make sure on your paper, as always, that you mark your axis and a scale. And then we'll graph the point 0, 0, 1, 1, 4, 2, and then 9, 3. And then remember, this graph does have a starting point. So we don't go through that origin down to where the x's would be negative. We have a starting point. And then the graph could continue. We could continue to plug in x values forever, positive x values, and our graph would continue in that direction. Let's identify the domain and range. So remember, our domain is limited. We need values that are either 0 or positive. And then because of that, we only get 0 and positive numbers out. Now, cube root is different. So we can plug in negative 0 and positive numbers and take the cube root. So let's go with even cubes, and let's start with the negative. So 8, or negative 8, is a perfect cube, negative 1, 0, positive 1, and 8. And then these values for both of these graphs are ones that we're going to come back to. So the cube root of negative 8 is negative 2. If I multiply negative 2 by itself 3 times, I get negative 8. Cube root of negative 1 is negative 1, 0, cube root of 1 is 1, and the cube root of 8 is 2. So I'm going to put my axis right in the middle. And then we'll start with our point negative 8, negative 2. So from the origin, I go over negative 8 and then down 2. From the origin, I go over negative 1 and down 1, stay at 0, 0, over 1 and up 1, and then over 8, 6, 8, and up 2. And then our curve, so I want to make a slide, I'm going to come up, and then I make this little jig jog, and then I continue. So it doesn't flatten out at the left and the right. It just continues to go up, up slowly. Then it does a little jig jog, and then up slowly again. And then if we don't identify our domain and range, so we don't have any limits. We can plug in any negative, zero, or positive real numbers, and then we will also get all real numbers out. All right, so make sure that you have those parent, square root, and cube root graphs there for your reference, because now we're going to start graphing some transformed functions. So look at the first examples, and this is like example 1 and 2 in the book, chapter 5, section 3. So first we're going to look at the equation and describe, and then eventually graph, but first we'll describe the transformation. So I have done that already. It's 3 to the right and 4 up, and this is a square root function. So we have figured out the transformation, and then I also have identified our h value. So our h value is the opposite sign from what we see. It's what's being subtracted, so it's 3. And then our k value is 4. And I have written my equation without my h and k value, because that's how we're going to plug points in. And then what we're going to do is either add or subtract those h and k values to the x and y to do the shift algebraically. So notice by my x, I have a plus 3. Since my h value is positive, when I actually look at what it is, what's being subtracted, well, it's 3, I know that my x values need to be shifted to the right, so I'm going to add 3 to my x's at the end, and then my k value is positive, I'm going to add 4. So if we plug in our perfect squares from 0 to 9, we'll get our square roots, and then what we do is algebraically we do the math and make the shift. So we don't have to put 2 graphs on there. It'll just be one transformed graph, and we'll have the best possible points that we can. So my shifted x values will be 3, 4, 7, and 12. My shifted y values will be 4, 5, 6, and 7. So those are the x and y values that I want to graph. Now I notice, again, I have lots of positives on my x and my y, so I'm going to shift my axis accordingly and still go by ones. Sometimes with these you won't be able to graph all the points. So now we're going to graph these x's and these y's, and that'll give us a transformed function. So our first point is at 3, 4. Our next one is at 4, 5, and then 7, 6, and then finally 12, 5, 10, 12, and then 7. Now remember, this is a square root function, so my graph has a starting point, so it starts there. And I look, and I can either look in my equation at my h value, or I can look at my graph, and I can see that my x values start at positive 3 and continue in the positive direction. So my domain is greater than or equal to 3. And then with my range, I notice that my y values start at 4 and then continue in the positive. So y is greater than or equal to 4. But as a little cheat, you can look at your h value. So the h value will help you determine the domain of your square root function, and the k will help you determine the range. All right, now look at the next example. Now I've worked ahead again, so remember you can pause the video to kind of catch up. I've identified that our h and k values are both 0, and all we have is an a value inside our cube root function, which means we have a horizontal shrink by the reciprocal of that number, which is an 1/8. And then the negative will give us a y-axis reflection. Now we're going to plug in our cube root values of -8, -1, 0, 1, and 8. Our multiplier of 8 will still allow us to have perfect cubes when we do that. So negative 8 times negative 8 is positive 64, and the cube root of positive 64 is 4. The cube root of positive 8 is 2, and then of 0 is 0. The cube root of negative 8 is negative 2, and then negative 64 is negative 4. All right. So I'm going to put my x and y axis right in the middle. And just go by my normal scale. So my first point is at negative 8, 4. And then my second one is at negative 1, positive 2. So I can see that I'm kind of stretched away from the x-axis. Then 0, 0. Then at 1, negative 2. And then finally at 8, and then positive 4. I'm sorry, negative 4. There we go. All right, and then I'm going to have that same, it's almost like a propeller. There we go. And I have that horizontal shrink. So it's shrinking away from the x-axis, which actually kind of stretches it out. Our domain of our cube root function is all real numbers, and our range is all real numbers. All right, we're back to a square root function, and we have the square root of 1/4 x. Our h and k values are 0, so no horizontal or vertical translation, but we do have that 1/4 multiplying inside the square root, so that's a horizontal stretch by 4. Now I'm going to plug in just my typical values, 0, 1, 4, and 9. So the square root of 1/4 times 0 is 0. Square root of 0 is 0. When I take it times 1, I just get the square root of 1/4, which is 1/2. I'm just going to write that as 0.5. And then a 1/4 of 4 is 1, so square root of 1 is 1. And then 1/4 of 9 is 9/4, and then if you think about the square root of 9/4, that will equal 3/2 or 1.5. So I'm just going to shift my xy axis over a little bit. Try that again, because I have lots of positives. Okay, so I've got 0, 0, and then 1, and then just a half, so I'll go up halfway. 4, and I'm going to go up to 1, and then finally 9, and I'll go up to just 1.5. So this is a horizontal stretch, which actually means it's stretching towards the x-axis, and so it flattens out. Vertical stretch would mean it would stretch up towards the y-axis, but a horizontal stretch means it's stretching towards the x-axis, and it actually looks like it's getting flatter. All right, so domain and range, if you think about that little cheat, you can look at your h value as 0. So for our x values, they have to be greater than or equal to 0 to get real numbers. And for our range, it's the same. It needs to be greater than or equal to 0. All right, let's graph this last cube root function. So again, our h and k values on this one are 0. So I bet you're thinking about what kind of shift or what's going to happen with this negative 3 out front. And, well, I don't have my equal sign in there, so I'm missing that. So let's put an equal sign, and then our a value is negative 3, and it's out front. So this is going to be a vertical stretch by 3. And then what that negative value will do is that it will be an x-axis reflection. So it's going to flip over the x-axis. And when we're graphing, we would only leave off our h and k values, but since they're 0, we don't have to worry about that. We're going to use just our perfect cubes as inputs just remembering that after we find it, we have to multiply by 3. So the cube root of negative 8 is negative 2 times negative 3 is 6. Cube root of negative 1 is negative 1 times negative 3 is positive 3. Cube root of 0 is 0 times negative 3 is 0. And then 1 times negative 3 is negative 3. And 2 times negative 3 is negative 6. So I'm sure you can see kind of this pattern going on right here. All right, so let's put our xy axis right in the middle. And let's graph. So we have negative 8 and then up 6. All right, and then we'll go, there we go, negative 1 and up 3. 0, 0. Okay, and then 1, 3. Sorry, 1, negative 3. And then finally positive 8 and then positive or negative 6. 5, 6, 7, 8. All right. So now it's the same motion, but we can see that it is definitely stretched out. And our cube root function, our domain and range are all real numbers, and you can tell that by the equation and also by the graph. All right, the last bit of the notes we're going to look at now. Just writing transformations with equations. Okay, so let the graph G be a horizontal shrink by a factor of a sixth, followed by a translation 3 units to the left, and we're starting with just the parent cube root function. Okay, so let's build this transformed function. So first of all, let's use G like they suggest, and then a horizontal shrink by a factor of a sixth. So that means our multiplier is actually going to be 6 right in by our input, our x. And then we want to go 3 units to the left. So that is an h value, and we're going to do the opposite. So we're going to subtract. And I want them just by the x. So I'm going to put a parentheses around this and say, what am I saying? Plus to the left. So yeah, I need to add plus 3. Okay, and then we could just rewrite this as g of x, come on, equals the cube root of 6x plus 18. Okay, remember you can put these on your graphing calculator and see if you're original and then you're transformed. Sorry, that's just Jack, my dog. Looks like it's doing what it should. All right, so now in this one, we're going to let G be a horizontal stretch by a factor of 2. So that means we'll be multiplying by a half since it is horizontal. So let's build this function. And then after that, we're going to translate 2 units up. Okay, and this is a square root function. So we'll do square root and then 1/2. Now we already have a 3 there and then an x. And then 2 units up, so we need to have that plus 2 out to the side. So if we simplify this, we'll get the square root of 3/2 x and then plus 2 out to the side. Okay, and then finally, we want our g function to be a vertical shrink. So our multiplier is going to be outside, and we are transforming this function here. So vertical shrink by a factor of a third, and followed by a translation 3 units right. So we're going to subtract 3. Okay, so 1/3 is going to be out front, and then x plus 5, but we want to shift 3 units right, so we're going, 3 units right, so we're going to subtract 3. So our final answer will be 1/3 out front. That'll give us the vertical shrink, and then x plus 2, which gives us that shift 3 units to the right from where it was. All right, that concludes the notes on Chapter 5, Section 3. So now you are good to go to do the assignment.